So now that we've talked about how Java 8 streams compare and contrast with other Java technologies, things like collections, things like I/O streams, and so on, what we're going to do now is talk about how streams compares and contrasts with other technologies above and beyond what you would find in Java. And the main reason I mention this stuff is just to give you the bigger picture view of the paradigm of stream processing, which is actually something that's been around for quite a long time and has a very important role in computing for many of the same reasons why it exists in Java as well. So I think we've talked about the fact that a stream is this sequence of data items that are conceptually produced one at a time and then processed in some kind of pipeline. So that should be no big surprise at this point, hopefully. And basically, the program can read items from an input stream one by one and also write items to an output stream. So that's kind of the paradigm. And then the output stream of one program can be the input stream to another. And maybe a better way to say it is that an output stream of one operation can be the input stream to another operation. This particular way of pipelining things together is actually captured nicely in other literature. In fact, it's been around for decades. We talked about this briefly the other day, but here's a more formal discussion, a more systematic discussion of the point. So if you take a look at a book called the Pattern-Oriented Software Architecture Volume 1 book, it contains a bunch of cool design patterns, one of which is called the pipes and filters pattern. And the intent of the pipes and filters pattern is to divide an application's tasks into multiple self-contained data processing steps. So if you take a look at the diagram, you can kind of see what this is going to do. The data processing steps are the things here called filters, which is, think a little more broadly than filter in Java 8 streams. Filter is just something that does some work to transform its input and produce the output. And so there's a bunch of filters, and those filters are connected together by these other data structures, which are called pipes. And the pipes have data buffers that can be used to store the data that's output from one filter and then input into the next filter. So you can kind of think of this again, it's like a pipeline, right? There's some input, comes in, it's transformed somehow, that writes to this pipe, that pipe is then connected into this filter, that does some processing, stores it into the next pipe, and that goes on and on and on until we're done. And if you don't have the Post 1 book and you want to read about the concept of pipes and filters, take a look at this paper, which was published about 9 years ago, talking about pipes and filters as a pattern and giving some cool examples. So obviously, there's many implementations of pipes and filters in real life. We talked about an example the other day having to do with water purification. So you could imagine water purification is one example. That's kind of a human known use of this pattern. But there's many other interesting examples as well. And here's one of my favorites. If you haven't had a chance to play around with this, it's probably worth at some point learning it because it gives you a very different view of how to write applications by simply chaining them together. And this is the famous pipelines that are on the Unix, that are supported by the Unix command line shells, like bash or TC shell or C shell or Bourne shell. There's all these different shells that have been created over the years. And they all have, on Unix at least, and I guess on DOS for that matter, they all have the ability to connect things together. So here's an example of a little program that's going to go get a list of all the files in /user/bin, which is one place that binary files are stored. It's going to pipe that through the sed filter, sed program, and sed is going to go ahead and strip the directory part. So it's going to go ahead and substitute anything in such a way that it's going to strip off the directory. And then what it's going to do is it's going to select certain elements with certain characteristics. Then it's going to sort the results, and then it will print everything as a single line. So this is typical Unix shell gobbledygook that people who are typically system administrators tend to get very good at because they do a lot of manipulation of file systems and input and output devices and so on. And so basically what happens is that information comes into the through the keyboard by somebody piping these things in, either typing them or putting them in a script. And then that goes through one program, and then that program will pipe the output to the next program. Each of these things is a program. That does some work, does some more programs. So it's basically a little pipeline or bucket brigade of processing. So if you have access to a Unix or Linux machine, you can try running that script to see what it does. It's kind of fun to see what it does. There's other examples of streams that exist in the history of computing. There's something that's called SystemFive streams, which was a framework that was developed by Dennis Ritchie, who is also one of the people who co-created Unix back in the day, back in the early 70s. And among creating Unix, he kind of liked this pipes and filters pattern. And so he came up with a little kernel resident framework for building layered protocol stacks out of modules. So you can see here, this is used at the user level. If you've taken the operating systems course, you have user processes. And then inside the operating system kernel, you have things that can communicate with external devices like a network interface or a file system or a terminal or whatever. And many of the types of things you need to be able to do in communication protocols like TCP/IP or UDP/IP or other protocols is have stacks of protocol layers that transform the protocol data units, the PDUs, as they flow up and down the stack. And so he came up with this really cool model that allows you to connect together these protocol stacks so data can flow in, and they'll flow through the different layers and have processing done to them, and then they're deposited up into the user process through some kind of queue. And likewise, when a user writes data from user space into the kernel, it'll again go through the layers in the protocol stack and then is sent out to the device. So once again, this concept of streams, very venerable, very effective, used quite commonly throughout the computing world for lots of different reasons. Okay, so just giving you a little bit of background on other technologies that have streams like processing models, and they're all based on this concept of the pipes and filters pattern, which is documented in the POSA 1 book.